Good evening, everyone. Hope you're all having a wonderful, wonderful little Saturday evening. So, we're back looking at the wonderful, wonderful Project Longshot. And I have a little bit of an admission. I've been doing a little bit of stuff between episodes here. Trying to get a little bit of performance running because last time it was really halting on the performance side. So what I've done so far is I've switched the Emscripten compiler to produce WebAssembly. So we've added these two commands to the compile line. So by generating WebAssembly, Chrome is a lot happier about rendering this. It's about the same for Firefox. Internet Explorer and Safari don't yet support this officially. For Edge, it's a prototype flag, so you can enable it. And for Safari, it should be coming in Safari 11. So that's not too much of a bad thing. And it allows us to it allows the compiler to be a little bit more optimal and to use like 64-bit operations when necessary. The other thing it does is this allow memory growth, which means that we don't have to like upfront allocate a gigabyte of memory. We can just dynamically extend the amount of memory we need and shrink it as well. So that allows us to not worry about how much memory we're using, at least not as strictly. So that's one thing, sort of a little compiler thing. The other thing that I noticed is that the more stuff we printed to the debug console down here, so the more stuff we put in the debug console down here, the slower the page would get and the slower our rendering would get. So I put an upper limit on that. So in our index.html here, we only keep like the last 1,000 lines or characters of text, and that really speeds stuff up. So apart from that, last time we got this running in the full window. We have our debug overlay. So the plan today is to make it a little bit more colorful. So sort of the first thing we're going to do is we're going to be adding a skybox so we don't have all this black here, but probably some light gray instead. Nothing too fancy because I can't really, my graphic skills don't get us that far. Second thing is I want to add some grass as well so that this becomes a little bit green on top. But we are going to start with the skybox. So the first thing we are going to do is we're going to switch over to the GIMP because we are going to be doing a little bit of graphics work. So the first thing we're going to do is we are going to create a new image here. Same 128 by 128 that the other images are. And we are just going to do this really simply to get something started. Is that we are going to find a nice bluish, light bluish color, and we are just going to try and fill that in entirely like that. And that is going to be sort of the sky. Really nice. So we're just quickly going to save, or I'm going to quickly save that out to our projects, to our textures. So this is going to be sort of the top of the world. If we just quickly switch here, we should now in our assets textures, we have a skytop XCF. We also need the appropriate PNM file because that's the file format we can read at the moment. So we're also going to export this as PNM, as ASCII PNM. There we go. Then in addition to that, we also sort of need a bottom. So for the bottom, we are going to take a somewhat lighter color. I'm gonna go for something here. So it's gonna look like that. Really, really wonderful colors. That is going to be our bottom. And export it as well. There we go. Now for the sides, we are going to blend these two colors together, which is going to be interesting. So I need a foreground background. Sounds like a good plan. I'm just gonna grab the old color as well. Add that in. That does not seem right. I'm going to switch over here, color picker. There we go. So we're going to do a blend from foreground to background. So if I do it like this, I get this nice blend. What we kind of want to do is we want to do it over a little area, and we want to make sure it's straight down. So we're just going to do something like that. And that's going to be our side. Yeah, that's why I'm using the blend tool in GIMP. So that is our side texture. And I'm going to export that as PNM. Again, ASCII. There we go. So those should be sort of the main textures we're going to need. So if we switch over here, we now have a couple of new textures. And we have our materials here where we have a stone YAML. What we want to do is we want to create another YAML file for a skybox. And so for this one, we have a texture sky. And instead of it just being one file, this has a top, which is going to be textures. So the idea here is we're going to use what's called a cube map, which is basically, if you imagine you have a cube around you, you have a top image, a bottom image, and then one for each of the four sides. So what we're specifying here are the images for that. So we have skytop.pnm. For the bottom side, we have sky bottom. And then we also have a front side. And there we go. So we have a front. We're just using the same texture on every side. So it's sky side. So we have front, left, right, back. So we have the front, we have the back, we have a left side, and a right side. Now we're going to need a different set of fragment or shaders. So we're going to use a skybox shader and a skybox vertex shader. So we now have the YAML file describing our materials. And at first we're just going to copy our wonderful little face fragment and vertex shaders. The skybox. Well, so we have all of that ready. So what we want to do is that we want in our main here, we have a renderable somewhere. A renderer here which renders a render list, which is just a list of GLES renderables. So what we would like to do is we'd like to add a skybox renderer to that. So what we're going to do is we are going to get a renderer here to create a skybox renderer. And it's going to do that for the material called skybox. And then it's going to render that at the end. So for our GLES renderer, it has the ability to create a chunk renderer. We'd also like to create a skybox renderer. And this is going to be for a standard string for some material. And then it's going to render that. So what we want to do is we are going to create a class. It's going to be called the skybox renderer. So this thing implements GLES renderable because we are renderable. So when we our GLES renderer here, in addition to creating a chunk renderer, which does a lot of fun stuff, we also, no, not renderable, renderer. We have create skybox renderer for some material. So what we want to do, again, we're just getting a pointer back. It's up to the renderer to maintain this. So we're going to again have an unordered map, this time from strings. Here, over to a unique pointer for a skybox renderer. And these are our skybox renderers. We of course need to tell you that we have a skybox renderer. So in our GLES renderer here, we essentially have the same idea. With this, we go for our look through our skybox renderers here, try and find it. If it's not there, then we're going to create one based on the material. So this is the skybox renderer. And just had a graphics reset, so that's a lot of fun. Anyways, we create the skybox renderer, grab the pointer from it. We want to save that into our skybox renderers using the material as our key. So we move that in so it takes ownership, and we return that. Otherwise, if it's already there, just return it already. So at this point, we have this hash only works for enumeration types. So when we are doing this, we don't have a hash function for standard string, which kind of weirds me out, but we're just going to do a normal map. So that means that I need to import map. So let's give that a go. So we can't allocate an object of abstract class type skybox renderer, because we don't have that class yet. So for this class, we want to have a skybox renderer which takes a constant standard string reference material. You can import string. And we have the normal for a GLES renderable. We have this wonderful render method here. So we have to implement that as well. And now we should just get undefined references, I'm hoping. Yeah, we have unresolved symbols because we don't know how to set these things up. Of course, No, not of course, because we don't need that. So we have our skybox renderer. So for construction, we should instantiate a material, which I am not entirely sure we have a So we have the ability to load in textures and stuff like that. PLES material is the one I'm looking for, because that's the one that we use. So for our skybox renderer, we have a lot of stuff going on here. What I'd like to do is, if I can find the header file here, is we need to have a private PLES material, which is going to be our material. And our skybox renderer is going to instantiate that material based on our given string, which is the name of the material. So we get all of this fun stuff, and we don't know how to render it yet. So for rendering a skybox, no, I don't want that one again, I want that one. We have a vertex attribute, normal attribute, texture coordinate, model transform, lots of fun stuff that we kind of care about, but not really. So for rendering this, what we want to do is we want to have a cube around the player, which we want to render. So what we are going to do is we are going to have a standard array and we are going to have it of float, GL float, and let's see what we were doing. We have a chunk render as well, which is great for reference, because this thing also has should have, there we go, nice big array here. Vertex data, we're just going to use DL floats. We're just going to have 4 of them. So what we are going to do, there's my skybox render, is we are going to have 4 times 8 of these, which are our wonderful, actually we're going to make that static vertexes. So our vertexes we can initialize nice and simply, because the skybox renderer's vertices are the 4 corners or the 8 corners of a cube. So if we start with 1, 1, 1, 1, and then we have -1 here. I'm just going to space this out so that it looks a little bit nicer. Then we can add -1 here. And finally -1 against the last couple here. And I need to tell you the type of these vertices, which is the same as over here without the static part, because it doesn't need to repeat that part. There we go. Then we also need to do the indexes in order to be able to render this. So for that, we're going to use PL shorts. GLU short because we need to index into that array. So we need 3 per triangle, and we have 6 faces. We're gonna need 2 triangles per face, so we need 3 times 12, and these are our indexes. So we're also gonna initialize those because they never change. So we are gonna start with, say, let's start with the X part. So that is, we need this, this, and this, and then we need these 3, which will give us 1 face. So for the first face, we grab 0, 1, and 2. For the second one, we grab 1, 2, and 3. Then we want to do the opposite face, which is these down here. So that means we grab 4, 5, 6, and 5, 6, 7. So 4, 5, 6, and 5, 6, 7. So that grabs us the positive X and negative X faces. So then we have positive Y, which is this, 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 and this. So that's 0, 1, 4, 5. So we ask 0, 1, 4, and then 1, 4, 5. Then positive Y or negative Y is these 4. So we grab 2, 3, 6, 7. So 2, 3, 6, and 3, 6, 7. Finally, we need positive and negative set. So that means we're here, 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 and here for the positive one. So that's 1 or 0, 2, 4, 4, and 2, 4, 6. And for the negative, it's 1, 3, 5, and 7. So we grab 1, 3, 5, and 3, 5, and 7. So there we go. Now we might want to do the same thing we did with the chunk renderer, where we then have the actual vertex buffers, and actually also so we have like generate index and generate vertex buffer, which actually creates the buffers needed, so that we just do that on initializing the first time. So how did we detect that? We check for whether vertex buffer is initted. So we want to do a similar thing over here. So what we do is we want to check, instead of calling it vertex buffer because we don't need it, we're just going to call it buffers initted, whether the buffers have been initialized. Then we have a vertex buffer and we have an index buffer. So for this, the reason why we're not doing like normals or we're doing texture lookups or texture coordinates is because we can deduce everything from the vertexes, because we're going to be using a cube map in a moment. So that makes everything nice and simple. We don't really need a lot of data for this. So what we want to do is we also, like in our chunk render, want to have a function. Just going to call it generate buffers in this case. So it's going to be generate buffers. And then in our initializer here, we're going to say if we do have our buffers initialized, then we are going to call generate buffers. And then we're going to mark the buffers as initialized. So one thing I really need to do here is I need to remember to set for our skybox render here the buffer initted to false. This is a bool if I'm not mistaken. It's not declared. I tend to disagree. Okay, buffers init. So it's initially false, and then we can call generate buffers. So Skybox renderer, the generate buffers function here. Well, we're basically gonna do the same thing as we've done for our chunk renderer, except we don't need to actually generate the data, it's already there. So we need to do this part for the index buffer. And we need to do, where is it? Actually, I like the name we've got over here, index buffer data and vertex buffer data. So we're gonna go with that. Index buffer data and vertex buffer data. That, then we also have a similar thing. So this is generating the index buffer. We also have a generate vertex buffer here, where we do all of this. So we're doing, for the index buffer, yeah, we're doing scale U shorts of that size. So here we have a vertex buffer data. It's the vertex buffer data size times GL float, and it's just static draw. So that initializes our vertex buffer and our index buffer with the data. So to render all of this, what we need to do is we need to get our material and activate that. So when we've activated that, we've activated the shader program and we've found all the textures needed, so the texture units, and we tell them that's a sampler to use, which is great. So yeah, that's good. Once we've activated that material, we just look over at our chunk renderer over here. We do a render call somewhere here. Then, yeah, generate the index buffer if it's not there. We then go through and we bind a lot of uniforms, which we also want to do here. So we have no local transform here. We just have the current transform, so we want to pass that into a model transform. So we're missing the value pointer stuff, and I can't remember exactly where that is stored. It's this thing, CLM-G2C type pointer. So we want to include that. So what we do here is that we start binding stuff, and we only need to bind the vertex attribute. We don't need to bind texture coordinate attribute or normal attribute, just that one. So this is the stride. We want to step 4 every time, and the offset into it is 0 because it's only vertex data. So it's nice and simple, and then we bind the buffer, and then we draw triangles based on the index buffer size. So that should be it. Now, we need the index buffer and vertex buffer don't have any text or definition. So what we need to do is we need to grab those from here and pull them over. So these are not static. Over on this side, they just need to exist. And declare them, and there we go. Now that should all link fine. And if we switch to the browser and try and reload, we should have, we get some texture named Sky. And then it looks like we sort of crash, which is not unsurprising because we're doing, yeah, uncaught exception. Exception catching is disabled. I'm gonna switch you over here. This exception cannot be caught. Blah blah blah.